You're watching the Weiss channel. Today, I want to talk to you about graphing relationships. What? Let's take a look. So let's recall that when you graph points, you have an x-axis and a y-axis. Along this way, right, is the x-axis, right? That's the x-axis. Okay. And then along this way is the y-axis, right? Okay, whoops. Okay, so does it make sense then that, say, this point right here would be 1, 6, right? Because x is 1 and y is 6. We always do x then y. It's always in the form of x and then y. Okay, so this point here, this point would be 2, 3, right? Because it's 2 and then on the x-axis and 3 on the y-axis. This point here is 3 on the x-axis and 5 on the y-axis. 3, 5. This point here is 5 on the x-axis and 1 on the y-axis. Okay. All right. So now let's take a look here. Right. Let's pretend for a moment that you're just going for a walk. All right. Going for a walk. And let's say you just go for a walk at the same pace the entire time that you're walking. All right. Does it make sense that a graph would look like this? Just the same pace, because as the amount of time passes, right, the amount of distance you go increases, right? So if you just keep a same pace the entire time that you're walking, it'll look something like this on your graph, okay? So let's say that you go for a walk, or let's say that you're going to do some moderate exercise. And let's say that you just start off on a walk, all right? Just a regular walking pace. But then let's say after a little bit, you decide, okay, you're going to pick up the pace and you go and you start running, okay? Does it make sense that it'll start going up higher, faster, because you're taking less time to go more distance? So the graph will go higher, faster, okay? Now let's say you take a break, you stop, you just completely stop, all right? Now you're spending time, but you're not moving, right? So the graph will look like this at this point, because you stop, you're spending time to take a breath or whatever, but you're not going anywhere. So you have flat, so it's flat, okay? So let's say you start walking again. You just start walking, okay? So it'll look like this, right? Now let's say you stop at Starbucks and you hang out at Starbucks and you get yourself a mocha frappuccino, all right? You're hanging out at Starbucks, okay? And then let's say after that, well, you go home. You go straight back home, all right? So does it make sense that the distance from home is now decreasing as you are walking home until you get all the way home, okay? So flat level is where you're stopped, right?
Good morning. If you're visiting the restaurant, please meet me in the
Flat levels are where you're stopped. All right. Moderate pace goes at a regular angle, but then it goes up faster if you're going at a faster pace. Okay. All right. So now let's take a look here. So here's an example of rainfall. Okay. Let's say you've got, let's say this is an example of rain. All right. So if it's raining, all right, at this point here, it's like raining moderately. Okay. But do you see how it like falls off a little bit here? So maybe it stops raining. I mean, not stops raining, but it's raining less hard. Okay. It was raining a little harder here, but then it eased off a little bit. Well, what's going on here? Here at this point, it goes from, say, 4 inches right up to 7 inches, like at this very moment. This means it just downpoured like crazy at that moment. And you had like 3 inches of rain, almost 2.5 inches of rain. So what does this mean right here? This means it just stopped raining right there. The rain stopped. And that's how much water has come down. In other words, 7 inches has come down. Okay. Okay. So take no, we're not gonna do this one. All right. Okay. So now take a look here. Here, trucks, all right? Let's say you've got a delivery van company, okay? And a delivery van is leaving the warehouse and then coming back for the day, all right? So here's an example of what it would look like for a delivery van, all right? So here, it's moving pretty quickly. That's getting out of the parking lot, right? There's no traffic in the parking lot. It moves pretty well. Now you're moving pretty steadily, but you're still in traffic, so you're not going fast because you are you're watching for other people in traffic. So now you're actually, what's this point right here? Isn't this actually making a delivery? You've stopped, right? You've stopped. You're not going any more distance, but time is continuing. So you're making a delivery. And then you go again, all right? You go to the next place, you're making a delivery. And here you stop again, you're making another delivery, all right? Now you continue, but you're actually on your way back towards the company, all right? You're on your way back, but you're also gonna stop here and make another delivery because that's how you worked out your route that day. And then you're getting back into traffic, okay? And you're just going a moderate pace. And then you, of course, get back into the driveway and you can go faster until you park, okay? And that's what that graph means. All right. Okay. How about this? All right. 3 hoses fill 3 different water barrels. A green hose fills a water barrel at a constant rate. Which one would that be? Which one would be the constant rate? Wouldn't that one be this guy right here? Constant, right? A constant rate. Okay. A black hose is slowly open when filling the barrel. Okay. So a black hose is slowly open. Wouldn't it make sense that that would be this one here, slowly open, and then it would open faster toward the end, okay? Then it says a blue hose is completely open at the beginning, like this, right? And then slowly closed. Okay, that's how that works. You and a friend are playing catch. You throw 3 different balls to your friend. You throw the first ball in an arc and your friend catches it. Here's your arc. This one's probably pretty obvious. And then it stops. Boom, your friend caught it. Okay. You throw the second ball in an arc, but this time it gets stuck in a tree. All right. So here's the arc, right? It gets stuck in a tree and that's it. It's not going anywhere. It stays there for the rest of time until somebody goes in the tree and gets it. All right. The third ball goes directly to your friend, right? But it lands in front of your friend, okay, at 0 distance, and then it just rolls toward your friend. Okay? Rolls the rest of the way on the ground. All right, that's how that works. Okay. How about this? A student is taking a test, and there are 10 problems on the test. For each problem the student answers correctly, the student receives 10 points. Now, do you notice that you don't have a line here? Why don't you have a straight line? You just have dots. Well, here's why. Because like here's 1, right? But right over here, that would be 0.5, right? Is there such a thing as getting half of a question right? Well, in this example, no, you don't get half a question right, or you don't get 3/4 of a question right. So there's not going to be anything in between getting 0 right and 1 right. Okay. So if you get 1 right, you just get 10 points. If you get 2 right, you get 20 points. If you get 3 right, you get 30 points, and so on and so forth. So that's what this graph looks like. Okay. And these points are not connected. When they're not connected, it's called discrete. So there's discrete and there's connected. All right. So this is called a discrete graph. Okay. All right. Good morning. So a bathtub is being filled with water. After 10 minutes, here's what it'll look like. So a bathtub is being filled with water, all right, and it'll go at a pace like that. After 10 minutes, there are 75 quarts of water in the tub. All right, so let me fix that. You go from here to 75 in 10 minutes. That's going to look something like that. Okay. Then someone accidentally pulls the drain plug while the water is still running and the tub begins to empty. The tub loses 15 quarts in 5 minutes. Okay, so from 75, you're going to go to 60, just like that. Okay. I am talking on the computer. I'm recording for the Weiss channel. You didn't know. That's all right. Don't worry about it. You're fine. The tub loses 15 quarts in 5 minutes. And then someone plugs the drain and the tub fills for 6 more minutes, gaining another 45 quarts. So 60 plus 45 is going to be 105, right? So that's going to be, oh, wait, for how much time? 6 more minutes. All right. So that's going to go to 21, 105, somewhere around there, right? That's not perfect, but that's what it would look like. Okay. After a 15-minute bath, all right. So 15 minutes means there's no water going in and no water going out. Okay, 15 minutes. After the 15-minute bath, the person gets out and pulls the drain plug, and it takes 11 minutes for the tub to drain. So this from here to here is going to be 11 minutes. And that's what that graph is going to look like. Okay. Okay, so take a look here. The graph shows the attendance at a hockey game and the rate at which fans enter and exit the arena. All right. So here, does it make sense that from here to here, fans pretty quickly enter the arena at the beginning? All right. But then, it's harder, as more people come in, it's harder to enter. And so then it slows. All right. And then there's no more people entering the arena. Okay. Because they cut off the entrance apparently. But then when they reopen it again, there's a lot of people that pour back in, and now probably the game starts. Okay. And people are watching the game for a while. Okay. Now, what could happen is, we're losing. So people get sick of it and they're like, well, I've had enough, and they start to leave. But then, maybe you score a goal and I want to stay. So no more people leave. And then the game ends. You get a lot of people leave, and probably a few people hang out, probably to maybe try to get autographs and stuff like that. And then after that, people start to leave. Okay, and that's what that graph would look like. Okay. Janelle alternates between running and walking. She begins by walking for a short period, then runs the same amount of time. She takes a break before beginning to walk again. Which one shows that? Okay. Okay, so Janelle starts between running and walking. Okay. She starts walking. That's going to be here. She's going to be at a slower pace. Okay. And then she runs for the same amount of time. Okay. So that's a faster pace. Okay. Then she takes a break. That's going to look like this. And then she starts walking again. That's this. So your answer is going to be here. Okay. During the winter, the amount of water that flows down a river remains at a low constant. Okay. So right there, that's either going to be this or this. Okay. Because you see how you're starting off constant here, you're starting off constant here. Okay. Then it says in the spring, when the snow melts, the flow of water increases drastically. Well, this one doesn't increase. This one does. There's the increase drastically. All right. Until it decreases to a steady rate in the summer. That's what this is. Steady rate in the summer. Then the flow slowly decreases like this in the fall into the winter. Okay. That's what this graph looks like. All right. Two children are selling lemonade. They're charging $1 per cup. They only sell 10 cups. Which one would that be? Well, once again, let's assume that they're not selling half a cup or a quarter of a cup. They're just going to sell it by the cup. So if they're going to sell it by the cup, you're not going to have a graph like this, because this means you have all kinds of different possibilities, like half a cup or a quarter of a cup or 3/4 of a cup. So here would be 1 cup, like 2 cups, 3 cups, 4 cups, 5 cups, 6 cups, etc. This is going to be your answer, right? A plane takes off and climbs steadily for 15 minutes, all right? So would look like this. steadily for 15 minutes until it reached 30,000 feet. Let me fix that, okay? It's gonna look like this. It's gonna go all the way up like this. Here's 30,000, all right, after 15 minutes, and then it's steady, all right? It travels at that altitude for 2 hours until it begins to descend to land, which takes 15 minutes at a constant rate. So here's another 15 minutes, goes down like that. There's your graph, okay? And this is called continuous, right? Because it continues, it doesn't stop. There's no, back here, this was called discrete because it stops and starts. But this is continuous because it's one fluid motion, okay? Continuous. Okay, so a contestant on a game show is given $100. All right, so let's say this right here is $100, okay? And is asked 5 questions. The contestant loses $20 for every wrong answer. So I get one wrong, boom, I lose $20. I get another one wrong, lose $20. I get another one wrong, lose $20. I get another one wrong, lose $20. I get all 20 wrong, I'm back to 0. That's how that one works, okay? You decide to hike up a mountain. You climb steadily for 2 hours. Okay. Take a 30-minute break, looks like that. When you make it to the summit, you enjoy the view for an hour. Then you continue to climb faster than before. When you make it to the summit, you enjoy the view for an hour. Then you climb down the mountain. Stop halfway down for a short break. Then continue down at a slower pace than before. Okay? That's how it works. You've been watching the Weiss channel.